Hello everyone, welcome to Look, Learn and Lead. Today, in the Simplifying System Design series, we will be talking about functional requirement, non-functional requirements, and real-time examples which will help us identify the functional and non-functional requirement of a given use case. What are functional requirements? Functional requirements are basically just the kind of inputs that are given to the system, what is the behavior of the system, and what are the expected outputs. It could include certain calculations, data manipulations, defined user interactions, and many such things. For instance, we have a login page, right? So usually in a login page, we'll have two parameters, username and password to login. So it's a kind of functional requirement. Another example here is suppose an application has two different kinds of users, say admin and a regular user, and we want to limit the data that the admin can see. Then the background color for all windows in the application should be gray or blue. So we are defining something here. So this is a kind of functional requirement. Non-functional requirements. Non-functional requirements are basically the quality of the system which is not quite explicit and cannot be seen in the functional requirement. Non-functional requirement usually analyzes the usability or effectiveness of the entire system. For example, irrespective of the number of users, a website should load within 5 seconds. If it goes beyond 5 seconds, we'll say that it's too slow. Then certain applications should be portable. That means that the software should run on different kind of operating systems, say Linux or Windows or any other OS. A website should be able to handle 30 million users without affecting its performance. Now, since we're clear about functional and non-functional requirements, let's go in depth of the non-functional requirements. One of the non-functional requirement is scalability. By scalability, we mean the number of requests a system can effectively support simultaneously. The point at which an application can no longer handle additional requests effectively will be called as the limit of its scalability. So when I say no longer handle additional requests, that means there's possibility that there is a failure in hardware, maybe due to less memory, network, bandwidth combinations. Okay, so when we say scaling, it might include any of the combination of adjustments to CPU, memory, or the network bandwidth. Achieving scaling without much performance loss should be our aim. Scaling can be done horizontally or vertically. What do you mean by horizontal and vertical scaling? So, suppose we have a system and at some point of the time the system is low on memory. One approach will be to switch that machine with a machine which has higher capacity. So that is called vertical scaling. So you keep on increasing the size of the instance. Horizontal scaling is more like the configuration of the resource remains the same, but we keep on adding additional resource. Second concept in non-functional requirement is high availability. So that means, is the system dependable enough to operate continuously without failing? What do we do when a system fails? We try to repair it or replace it with a spare. So we have to make sure that particular downtime in doing that is least. So that's when we say the system is highly available. So downtime comprises of repair time, availability of the spares, recovery time, and other logistic considerations. Next is efficiency. So when I say efficiency, two things are taken into consideration, the response time and the bandwidth. So when I say response time, it's the time between the submission of a request to the system until the request has been completed and reaches back to the user. So it's more like latency. So we need to have low response time, right? the latency should be minimum. Then the second is bandwidth. So how much data is being transferred successfully from the source to the destination? That's what defines the bandwidth. Fault tolerance. Fault tolerance means we have to make sure there is no single point of failure or bottleneck. The idea here is that the system should be able to continue operating without any interruption, irrespective of whether a component is failing or not. So when we say the components are failing, obviously we have to have backup components. So we have to ensure that there is no single point failure. So backup components will ensure there is no loss of service. Consistency. Consistency we can categorize into two things. One is strict, strong or immediate consistency, and another is eventual consistency. So the name itself suggests that strict, strong or immediate consistency guarantees that the client always sees the latest data. So suppose some update has been done to the data in the data store, and the data viewed immediately after that update will be consistent for all the viewers or all the users who are seeing that data at any point of time. Eventual consistency, as the name suggests, if no new updates are being made to a given data item, eventually all the access to the data item will return the last updated value. That means after the update, immediately if the data is viewed, not all users will see the same data, but the point here is if the data is inconsistent, it doesn't matter if it is consistent eventually. Durability. Durability is an important concept which defines how long the data should reside in the data store, right? It shouldn't be like you are updating your data and the data is lost. It shouldn't be that the data is residing there forever. There has to be a life expectancy for that data. Like at some point of the time, the data is going to become irrelevant. So you can always give a time to live TTL or that kind of a tag to particular set of data. So now we'll be discussing about some real world examples, and we will identify the functional requirements and non-functional requirements. So the first one here is an online cab booking system like Uber, Ola. Functional requirement will be we would need accounts. One would be like a passenger account and then a driver account, right? So interface of the passenger should allow them to see the nearby drivers, see their own location, request or book a ride to a location, see the expected time of arrival of the cab that has been booked, how much they have to pay when the ride would be done, and they should have their previous ride informations also if they want to see it. The interface for the driver basically should inform the system he's to accept the ride. He should be able to accept the incoming request. He should be able to see the expected time of arrival and the amount to be paid for the ride to himself, right? Because that's how he will make sure that the amount has been paid or not. Then once the ride is done, he should be able to complete the ride and be ready again to accept the next ride. There could be other custom requirements like driver and passenger can rate each other. We can keep the data for some analytics and monitoring purpose as well. So when I say analytics, like in a day, how many passengers has booked a cab in a particular area, and that can be used in future to identify hotspots, like which area has more customers, right? Then we have non-functional requirements. So we have to make sure that the performance of the application is really, really good. In case of especially scenarios where the passenger places the request, the driver receives the request, accepts it, and then there's a confirmation going to the passenger saying the ride has been accepted. So any latency there, that means the application is not good enough. Then fault tolerant, obviously we have to make sure that there is no single point of failure. High availability, yes, high availability. It shouldn't be like the driver is booking a cab and some machine crashed and then there is no information coming back to the user, everything is lost. High consistency, durability, scalability. So these all requirements are necessary for an online booking system. The second example that we are going to discuss here is a chat messaging application like WhatsApp or Facebook. Functional requirement will be like the user should have his own account. So we can link the account with the phone number or email or give a username and password depending upon the requirement of the design, right? The user should be able to send and receive chat messages, do a group chat, send and receive images, document, audio, video file, track message status, so whether the message is delivered or whether the receiver has seen the message or not, get notifications about the incoming messages if the user is not online. We could have other custom requirements, say analytics or monitoring, app web support, like they should be able to log in via some website or web support, ensure that the data is secure, so we could add some encryption decryption when the data is sent. Non-functional requirement, of course, performance. There should be less delay in delivery of the messages when the user is sending a message. Of course, fault tolerant, it should be highly available, consistent, scalable, durable. Designing YouTube or any other video streaming applications like Netflix, Hotstar. Here we have functional and non-functional requirements. Again, we would need account, two kinds of accounts, uploader and watcher. So the uploader should have his or her own channel, should be able to upload videos to the channel, should be able to see information like number of views, likes, dislikes, how much he earned, maybe overall per video basis, and maybe such information, right? Then the person who is watching those videos, they should be able to view, share it, like, dislike, add, comment, subscribe to different channel. And the very basic is perform the search based on some keyword or the title of the video. We can add custom requirements also, use that data for analytics and monitoring, and recommend user with the latest video on certain criteria like most watched video, most searched video, those kind of things can be added. Again, non-functional requirement, all these are important. Performance or the way the video is being loaded, we have to make sure it gives a real-time experience. There should be no lag. It should be fault tolerant, highly available, consistent, scalable, and durable. But again, consistency may not be required for all scenarios. Suppose somebody is adding a comment or liking the video, it may not be necessary for it to reflect immediately to every other viewer or in fact the uploader. It could be done at later point of time also. So consistency may not be a necessity in all scenarios. Specific scenario, the data consistency is important. So this is what is a requirement and non-requirement gathering process for a system design is. In the future videos, I will be talking about other system design components like load balancers, cache, and data sharding, and how these are going to help us achieve our functional and non-functional requirements.